In this video, we will do our first review for the Semester 2 final exam. So we start with the trig part. So we're going to do some graphing to begin with. So for our sine curve, we're going to factor, I'll go back to the white. Let's factor out that 1/2, and then we'll try to figure out our period. So if we take out 1/2, then that's going to divide by 1/2, which is multiplying by 2, which will make that be a pi over 3. So our period is going to be the normal period 2 pi divided by our b, which is going to make our period be 4 pi. So our critical points, which are going to be our tick marks on the graph, are going to be every fourth of a period. Our amplitude is going to be the absolute value of that A, so that's going to be 2. So we're going to translate this up 1, so I'm going to put a dotted horizontal line at y equals 1. Since our amplitude is 2, I'm going to go 2 up and 2 down from there, so that's going to be at 3 and at -1. So those are going to be the boundaries of our graph. We're going to start at pi over 3. So I'm just going to arbitrarily call that pi over 3. And then since our tick marks are spaced every pi, I'm going to add pi to the pi over 3, which will make that be 4 pi over 3. And another 3/3 will make that 7 pi over 3. And another 3/3 will make that 10 pi over 3, and one more to get to 13 pi over 3. So our sine curve is going to start in the middle, so we're going to be at 1 at x equals pi over 3. Because of the negative, we're going to go down first, then back to the middle, up to a high point, and back to the middle, and that's one full cycle or one full period of our sine curve. All right, let's try the next one. We're going to do a secant. So remember, secant is the reciprocal of cosine. So what we're going to start with is graphing our cosine curve. So we'll factor that pi over 4 out. And so we can see that our period is going to be the same as it was for the sine curve. We start with a natural period of 2 pi divided by pi over 4 will make that be 8. So our tick marks are going to be every fourth of a period every 2. And the amplitude for our cosine curve, a secant curve doesn't have an amplitude, but our amplitude for the cosine curve is going to be 3. So let's see, we're going to translate this down 2. So here is -2, and our amplitude being 3, we're going to go up to 1.
Alberto, please come to.
So up to 3 and down to -4 are going to be the high and lows for our cosine curve. So the cosine is going to start at -1. So I'm going to go, there's -1. And then our tick marks are every 2. So there's going to be 1, 3, 5, and 7. So our cosine curve starts big. So it's going to be here, then to the middle, to a low point, to the middle, and to a high point. So here is our cosine curve. I'm going to change colors. And well, first I'll put in the asymptotes. So where this crosses our translated midline is going to be where that cosine is going to be 0, which will make it undefined. So our secant is going to share the high point and go up, share the low point and go down, and then we'll get one more little half curve there. So there's one full cycle, one full period of our secant curve. Let's try it with a tangent. Okay, so Again, we're going to factor that 2 out so that we can get an idea of what the starting point and period are. So factoring out a 2 divides by 2 makes that pi over 8. So a tangent curve, so our period, the natural period for a tangent is pi. And we're going to divide that by 2. And so that's going to make our critical points be every fourth of a period, which is going to be pi over 8. And we don't talk about amplitude with a tangent. So let's see, we're going to start at pi over 8. I'm going to arbitrarily call that pi over 8. And then we're going to go tick marks of pi over 8. So that will be 2 pi over 8 or pi over 4. And then another will put us at 3 pi over 8. Now a tangent, remember, starts in the middle. And so our middle is going to be at pi over 8, comma 1. So I'm going to call theirs 1. And so pi over 8, 1 is going to be right there. Now normally we would go up 1. So I'm going to call that 1, there's 2. But because we are shrinking this vertically, we're going to go up just a half. And then the next critical point is going to take us to a vertical asymptote. So this is going to take off and go up in this direction. Going left, 1 puts me right at the origin, and then another one will put us at a negative pi over 8, and that's going to be our asymptote on the left. So going down a half is going to put us right there at a half on our y-axis, and then we're going to dive down and go to negative infinity. So there's one full period of our tangent curve. Okay, now we're looking for exact value. So if you think here now, 5 pi over 6 is going to be over here in quadrant 2. The reference angle is going to be pi over 6. Sine of pi over 6 is 1/2, and sine in quadrant 2 is still positive, so that's going to be a positive 1/2. 4 pi over 3 is going to put us here in quadrant 3. There's 1 and 1/3 pi, so our reference angle is pi over 3. Cosine of pi over 3, it starts big and gets small, so that's going to be a 1/2. And in quadrant 3, cosine is negative, so that's going to be a negative 1/2. Tangent of 11 pi over 6, we're going to think of as sine 11 pi over 6 over cosine of 11 pi over 6. So 11 pi over 6 is going to put us all the way here in quadrant 4 with a reference angle of pi over 6. So in quadrant 1, sine of pi over 6 is a half, and cosine of pi over 6 is square root of 3 over 2. In quadrant 4, the sine is negative, but the cosine is positive, and so when we multiply by that reciprocal, we're going to get, the 2's will cancel, we'll get a negative 1 over square root of 3, which we will rationalize in order to get negative square root of 3 over 3. Okay, now cosecant is 1 over the sine of 7 pi over 4. Notice we take the reciprocal of the sine. It does not take the reciprocal of that angle. 7 pi over 4 is 1 3/4 pi. That's going to take us all the way to quadrant 4. Our reference angle is going to be pi over 4. So sine of pi over 4 is square root of 2 over 2. In quadrant 4, sine is negative. So we're going to multiply by the reciprocal. That's going to be negative 2 over the square root of 2. And that is going to become just the negative square root of 2. And secant of pi over 3 is going to be 1 over the cosine of 2 pi over 3. 2 pi over 3 is going to be in quadrant 2. Its reference angle is pi over 3. the cosine of pi over 3 is 1/2. In quadrant 2, the cosine is negative, and multiplying by the reciprocal will get us that the secant is -2. A cotangent is a cosine of 3 pi over 2 over the sine of 3 pi over 2. So if we think on our unit circle, 3 pi over 2 is going to put us right on the y-axis. The coordinates of that point are 0, -1. The cosine is the x-coordinate, and the sine is the y-coordinate, and 0 divided by anything is 0. Okay, now these are where it gets a little tricky. Sine of 7 pi over 6. Remember, 7 pi over 6 is going to be this angle in quadrant 3. Its reference angle is pi over 6. Now, normally we would think that an inverse of a function, f inverse of f of x, would just cancel and give us that 7 pi over 6. But we have to remember that an inverse sine is going to be in between negative pi over 2 and positive pi over 2. So we need an equivalent angle for this 7 pi over 6 that's in between negative pi over 2 and positive pi over 2. So since sine is negative in quadrants 3 and 4, that's going to give us this angle, and this is the angle we want. That is going to be a negative pi over 6. That's the one and only correct answer to the inverse sine of the sine of 7 pi over 6. Now, cosine of 5 pi over 3, we go, there's 3/3, 4/3, 5/3 is going to put us here into quadrant 4. The reference angle is pi over 3. Now, an inverse cosine, its range, it has to give us an answer that's between 0 and pi. So 5 pi over 3 doesn't fit in there, so we need the equivalent angle, and cosine is also going to be positive in quadrant 1, so we need the angle between 0 and pi that will be the same as the cosine of 5 pi over 3, and that's going to be pi over 3. And for our inverse tangent, 3 pi over 4 is going to be here in quadrant 2. Its reference angle is pi over 4. Now, an inverse tangent has the same range that a sine does. So it's going to have to give us an angle in between negative pi over 2 and positive pi over 2. So remember that a tangent in quadrant 2 is negative. It's also going to be negative in quadrant 4. So an equivalent angle for a tangent of 3 pi over 4 that's between negative pi over 2 and positive pi over 2 is going to be a negative pi over 4. Then we move to what we think of as the calculus kinds, because we do this kind of stuff next year in calculus. So we want the secant of the angle whose sine is x over 3. So we're going to draw an angle in quadrant 1. We're going to assume that everything is positive, so that x is positive. That puts us into quadrant 1. Remember, an inverse sine is an angle, and we want its sine, opposite over hypotenuse, to be x over 3. So using a little Pythagorean theorem, we'll get that the adjacent side is going to be the square root of 9 minus x squared. Now, cosine would be adjacent over the hypotenuse. The secant is going to be the hypotenuse over the adjacent. And we have agreed that we aren't going to try to rationalize when we have variables in the radical in the denominator. So we're going to call that good. In a similar fashion, we're going to draw our angle this time, also in quadrant 1, so that its cosine is 2x. Cosine is adjacent over the hypotenuse. when we do some Pythagorean theorem, we're going to get 1 minus, and the quantity 2x is 4x squared. So that's going to be the square root of 1 minus 4x squared. The tangent is going to be the opposite, the square root of 1 minus 4x squared over the adjacent, 2x, and that is our answer. And finally, we'll draw our angle, also in quadrant 1, whose tangent is 5 over x. That's opposite over adjacent. From Pythagorean theorem, we're going to get the square root of x squared plus 25. The cosecant of this angle, since sine is opposite over hypotenuse, this will be hypotenuse over opposite. And there we go. Hopefully we're brushing the cobwebs off here.